Welcome to the video on perceptrons in deep learning. Before we delve into the world of artificial neural networks, let's take a moment to marvel at the incredible power of the human brain. With billions of interconnected neurons, the human brain is a remarkable organ that enables us to perceive, think, and learn. Its intricate structure and complex networks allow for astonishing feats of cognition and memory. It's this awe-inspiring biological wonder that has inspired scientists to create artificial neural networks like perceptrons, aiming to replicate the brain's remarkable abilities. At the heart of human brain's remarkable capabilities lie neurons, the building blocks of our nervous system. Neurons are specialized cells that processes and transmits information using electrical and chemical signals. They consist of three key components. First, you can see that the large portion on the left hand side is the cell body. Next comes the hair-like structures that moves out and comes into the cell body as well as at the terminal. They are called as dendrites. And the pipe-like structure in the middle of the entire neuron comes the axon. As I said, these hair-like structures are called as dendrites. Then the circle in between, which is called as the heart of the entire neuron, and the part other than nucleus is called as cell body. Cell body is directly attached to the pipe-like structure which is called as axon, and the part where this entire axon terminates is called as the axon terminal of that particular neuron. Now again you can see that there are hair-like structures at the axon terminal, and these are nothing but a connection from one neuron to the other. Now this particular neuron will be connected to the dendrites of the other neuron through this axon terminal. So this is nothing but a neuron. Now you might be wondering that why I am teaching you biology. It's just that the topic that we are going to learn in this particular video is nothing but a part of deep learning, which is perceptron, and this perceptron is weakly inspired by this particular neuron, which is building block of the entire human brain. Now how it works, let's see. Now in our day-to-day life we face many situations. Now from these situations we can get certain information. From this information we can understand what to react, how to react, and why to react. And accordingly we do so. Now how this process entirely works, this is just because of neuron, which is nothing but the basic unit of human brain. Dendrites in this particular neuron is nothing but a pathway through which information enters into the larger part of neuron, which is nothing but the nucleus part. Here the entire information that is collected will be processed. Whatever situation arises in your day-to-day life, the information that is collected from that particular situation will be processed here. That means according to the situation, what response must be made will be decided over here, and once the entire processing is done, this processed information will be then passed on through the axon, which is nothing but a pipe-like structure. Now as I said, this axon terminal is nothing but a connection between one neuron to the other. So whatever processed information has reached at the terminal of the axon will then be supplied to the other neuron. And similarly the information propagates, and that is how you can decide what exactly to respond on a particular situation. The entire process that happens inside the neuron is very much complicated, but this is responsible for a human to learn, to perceive, and to react for any particular situation. So inspired by this particular architecture, why not to create an artificial scenario where by using this particular simple approach, computers can also be able to think, react to a particular situation. So similar to neuron, you can see that here also we have three parts. First is the input part where the information enters. The second part, the information is processed, which was the nucleus part in the neuron. And in the third part, the information that is processed will be converted in such a way that it will be called as output. Though perceptron is inspired by neuron, but in reality it's not completely inspired because neuron is very much complex and a lot of intricate processing is done in neuron. Perceptron is simple comparatively. We are just taking an input, we are processing it, and we are converting the processed information in such a way that it will be termed as an output. So this is perceptron. So let's have a look at every single part in detail. Let's start with the input part. Here you can see that we have two nodes. Now this input nodes represents the features or variables that are fed into the model to make predictions or perform a classification task. Basically these are features, or you can say the variables from which you need to make predictions or classification. Now you can see that we have two nodes over here. It represents that the input has two features. If you have more than two features, then the number of nodes also increases. For example, let's take an example of this particular data set. Here we have a temperature column, then we have humidity column, and based on these two factors we have a climate column which says that whether the climate is tropical or it is balanced. So you can see that in this particular scenario we have two features, that is temperature and humidity, which are nothing but the variables through which we are going to classify whether it is a tropical climate or balanced climate. So in this particular case, since we have two features, therefore we have two nodes as an input. Now if we have three columns, let's say we introduce one more column, that is pressure, then in that case we will also have to include one more node in the input layer. So I hope the significance of the input part is clear to you all in Perceptron. Now, since we have completed this input section, let's come to this particular section which is directly attached to the input layer. And this section is nothing but the connection to the next section. And what these connections represent? This represents weights. Weights determine the influence of input feature on the output. It is a numeric value which tells how much important a particular feature is. Let's say we have two features over here, that is x1 and x2. The weight associated with x1 is w1 and the weight associated with x2 is w2. Now let's say if w1 value is greater than w2 value, then it says that x1 feature which has the weight w1 is more significant than the x2 feature. That means x1 feature plays a very important role in determining the classification or prediction. So I hope the importance of this particular concept weights is clear to you all. Now obviously at the initial phase we don't know which feature is more important. Therefore we initialize all the weights to 0 or with any other random number. Make sure that you should keep all the weights same at the initial stage because you don't know which feature is more important than the other. So now I am sure that this concept of weights is clear to you all. This weights concept plays a very important role in determining the prediction or classifications. Now let's move on to the another section of perceptron, which is the bias section. So this bias section again has two parts. First is the bias term. Now this bias term x0 is called as a variable, which is nothing but an input to the perceptron. Now this particular input is independent of the features that you are going to be using for prediction or classification. It acts as a virtual input. Now the main aim of introducing this bias term in the perceptron is just to have an independent variable in the network which will not be influenced by the features that you are using. It is always set to 1. This x0 term is constant. We are actually concerned with the weight that is associated with this particular x0 term. That is why we always initialize this x0 term to 1. Now since this bias term is a virtual input, there has to be a weight associated with it, which is called as w0 or it is also called as b. Now this weight that is associated with the bias term is nothing but a numerical value. You will clearly understand the importance of this bias weight in the upcoming videos. Now that we have completed this bias term, let's move on to the next section of the perceptron. This is a very important section, and if you remember in Neuron also this particular section was used for processing the information. Here also this particular node is used for processing the information or the input that is collected from all the features and the bias weight. Now what does it exactly do? It calculates the weighted sum of all the inputs. That means the value of the input multiplied by the weight that is associated with it. In this case, it is x0 into w0. Similarly, it will do it for all the features. And finally, it will sum up all them. and that is why this particular node has a summation sign. You can see it is represented by summation I equals to 0 to n because it starts from 0, xi, wi. Xi means, let's say, x1, and wi means the weight that is associated with it, that is w1. So it will multiply it, and similarly for the feature x2, xi is x2 and wi is w2. So it will multiply it. So whatever multiplication we have got for all the features input, we will add it. So here you can see the final expression as x0 into w0 plus x1 into w1 plus x2 into w2. Now this particular processing will done in this particular stage, and once this processing is done, a numeric output will be generated and it will be then passed on to the terminal of this particular perceptron. This terminal has a node which has its own significance. Now what exactly it is? Let's see. This particular node is called as activation function node. Whatever output we got from the weighted sum of the inputs, that output will be given as an input to this activation function and it will generate an output which will be the final output. Now there are a lot of activation functions. Following are the example. We have step function, sigmoid function, ReLU function, leaky ReLU function and tan hyperbolic function. We also have other activation functions, but these are some of the popular ones. This activation function is going to take the output of the weighted sum and will transform into a particular range. We will take an example by which you will be able to understand what exactly it is. So this is the entire perceptron. I'm sure that you might have got an overview of every single section that is associated with this particular perceptron. So to summarize, the first section is the input section from which the input features value will be taken. In addition to this, we also have one more input, that is the bias term, which will always be initialized to 1. Now we also have the weight associated with all these input features, and next we'll calculate the weighted sum of all these input features, and finally we'll transform it into a particular value through the activation function, and that will be the final result. So I hope this perceptron is clear to you all. Now let's see the different phases that this perceptron algorithm have. So perceptron algorithm consists of two key phases. The first is the training phase, similar to any other ML or DL algorithm. So in this particular training phase, the perceptron will try to adjust its weights. If you remember, weights are nothing but the importance that defines a particular feature. So in every single iteration, perceptron will adjust its weight. Now it will do this for all the records that are present inside the input. The perceptron will adjust its weight in such a manner that it will minimize the error. That is nothing but the dissimilarity between the predicted and the actual output. Now how this perceptron adjusts its weight, don't worry about it. We are going to look into the detailed mathematical intuition behind it in the upcoming videos. Now once perceptron is done with its weight adjustment, the next phase comes into picture. The next phase is testing phase. Now in this particular phase, the trained perceptron will have the final weights, and the final weights are going to be helpful for prediction or classification onto an unseen input data. See, we have a seen dataset and we have an unseen dataset. Seen dataset is nothing but the dataset which is used for training purpose. Once the training is done, we use the unseen dataset which is used for testing or checking whether the model that we have created on training is robust and accurate to unseen scenarios. So I hope these two key phases of perceptron is clear to you all. Now that we have seen an overview of the entire perceptron concept, let's have a look at these two phases with an example. Now here we have taken a simple example of the same data set that we have seen earlier. Here the data consists of temperature and humidity, which are acting as features. You can see that temperature can be called as x1 and humidity can be called as x2 feature. You can see that from the entire dataset, we have only these two columns as features because these two are acting as an input to predict the output that is called as label. The climate column is called as label because this is the output column. Based on the features, temperature and humidity, we are going to find out whether the climate is tropical or it is balanced. We will represent the tropical climate by the numeric value 1 and we will represent the balanced climate with the numerical value 0. Now let's focus on the first record. Here we have the first record in which the x1 value is 32 and the x2 value is 80, which is nothing but temperature and humidity respectively. So I hope this x1 and x2 part is clear. Now we are left with the w1, w2 and w0 values. As I already told you, the weights are not known to us initially, so it is always initialized to a random number. Let's take 1 in our case. So w1, w2 and w0 weights are initialized to 1. As I already told you that x0 is a virtual input which will be constant and the value that is assigned to it will be always 1. Even after training, it won't change. It will always be remaining as 1. So I think now we are ready with every single input so that we can process it and calculate the weighted sum. So you can see that once we are ready with all the inputs and weights, now it's time to calculate the weighted sum. You know that weighted sum can be calculated with the help of the formula xi into wi. So it starts from 0, hence x0 into w0, here in our case x0 and w0 both are 1. So 1 into 1. Next we have x1 into w1 which is 32 into 1. Next we have x2 into w2 which is 80 into 1. Now you can see that after calculating it we get 1 plus 32 plus 80 and when we add all this we get 113 as the output of this weighted sum. So this 113 output will be then passed on to the activation function which is the next phase. So let's write 113 here and this will be acting as an input to the activation function. Now I already told you that activation function is going to transform the input in such a manner that it will be called as final output. Here we are going to use the step function as activation function. So basically this step function takes an input and returns a binary output based on a threshold value. Now this threshold value can be set by us or usually it is 0. Step function can be represented in such a way. Step of x where x is the input is equal to 0 if the value x is lesser than 0. Here the 0 is the threshold value. The output will be 0 if it is negative, that means if it is lesser than 0. Otherwise the output will be 1 if the x value is positive which is nothing but greater than or equal to 1. Therefore, if we look carefully in our case, we have the x as 113. Now you can see that 113 is a positive integer and therefore the step output of 113 will be 1. So the final output of this entire input will be 1. And if you remember, we were representing 1 as tropical climate. So for this particular input 32 and 80, we have got the prediction as tropical and which is exactly same as the actual output which is also tropical. So in this particular situation, do you think that we have to change anything in the perceptron? No, right? Because our perceptron is predicting very correctly for this particular record. The error here is 0. The actual output and the predicted output both are same. So in this particular case, we don't have to manipulate anything in the perceptron because it is correctly predicting. Now let's move on to the next record. Here in the next record, we have the temperature as 25 and humidity as 60. So you can fill x1 as 25 and x2 as 60. These are the input features. Now, as you already know that in the previous case we had set the weights to 1 and since the perceptron was predicted correctly for the previous case, hence we haven't changed any single weight. Therefore, the weight here will also be 1. Now, let's calculate the weighted sum. So after calculating the weighted sum with the help of the formula, we have got the value 86. Now here the weighted sum is 86. Now this weighted sum will be acted as an input to the activation function. Again we'll use the same activation function, which is step function. If you remember, step function gives the value 1 if the integer is positive, and it gives the value 0 if the integer is negative. In our case, the integer 86 is positive, therefore we will get the final output of the step function as 1. We represented tropical as 1, therefore the predicted output for this particular record is tropical, but it doesn't match with the actual output of this particular record, which was balanced. So here you can see the error is 100%. Here our perceptron has not correctly predicted. Therefore, there is a need to change something in the perceptron so that it will correctly classify this particular record as balanced. And that something is nothing but the weights, that is the W0, W1 and W2 numerical value. So in this particular situation where the classifications are not correct, the perceptron will try to adjust the weights. Now how it adjusts the weight, we will look into it in the upcoming video. But for now, just remember that it will adjust the weight in such a way that the output here will now be balanced. And similarly, it will do it for all the other records. Wherever misclassifications are observed, it will change the weights in such a way that the classification will become correct. And this is how perceptron trains itself. Once all the iterations are done, the perceptron model will become ready for the next phase, which is testing phase. Now, as I already said that in the testing phase, we use unseen data just to check the robustness of the model. So as I've already said that after adjusting the weights and bias for all the iteration, general expression is finalized. General expression is nothing but the expression which we were using to calculate the weighted sum. As you know, in the general expression only the weights are manipulated. Therefore, after proper training, the weights will be finalized. So let's say in this particular case, we have the new weights that are obtained after training as follows. You can see that the model will now finalize the numerical values of W0, W1 and W2 as minus 250 for W0, 2 for W1 and 3 for W2. Here I have just used any random weights just to show you how testing works. So now these finalized weights will be now put into the general expression. Now the general expression is this: x0 into w0 plus x1 into w1 plus x2 into w2. We already know x0, x1 and x2 are the inputs. Let's replace the weights w0, w1 and w2 with these values that are finalized. So here the expression becomes something like this. So the final general expression is x0 into minus 250 plus x1 into 2 plus x2 into 3. Now let's test this for unseen data, that is the temperature is 25 degrees Celsius and humidity is 50%. So whenever an unseen data comes, we can use this general expression to find out the actual predictions for this particular unseen data. So as we know this expression, in this we just have to fill the x0, x1 and x2 values. We already know that x0 will always be 1. In this case, x1 is the temperature value, which is 25, and x2 is the humidity value, which is 50. So if we multiply these terms, we get minus 250 plus 50 plus 150, and when we add all this, we will get the final value as minus 50. Now this is the output of the weighted sum. Now we will apply the step function for this particular output. As you know, step function for any negative input will generate 0 as the output. And as you know, 0 represents the balanced class. So our prediction says that when the input temperature is 25 degrees Celsius and the humidity is 50%, then the climate is balanced. So this is how testing is done in Perceptron. I hope the entire process is clear to you all. We just have to calculate the general expression from the training process, and this general expression can be used for predictions and classifications of any input. I hope the entire concept of perceptron, the flow it has, and all the phases it includes is clear to you all. In the upcoming videos, we'll be looking into the intuitions behind perceptron, so stay tuned for that. In this particular video, if you guys face any doubts or queries, then please feel free to put it in the comment section. I'll be really happy to solve all your doubts. And if you guys have any reviews or suggestions regarding this particular video, then also put that in the comment section. Please share this playlist with all your friends so that they will also get benefit from this. And last but not the least, do like, share and subscribe to my channel. Also hit the bell icon so that you will always be notified first whenever I come online. And finally, don't forget to follow me on Instagram. Thank you so much for watching. Have a good day ahead.